Okay, so is data science really the sexiest job of 21st century? Well, in this webinar, we're going to find that out, of course, using facts. So agenda is, at the end of the session, you will be able to know why data science is the most sought after job in 2015, career opportunities with data science, advantages, and understands how companies are using data science so that you can mold your skill sets accordingly. So data science is a very vast domain, and and you'll have to focus on certain areas if you mastering, let's say, most of the areas where data science deals in. So in that case, you'll want to land up being the jack of all trades. I'm so sorry, my throat is bad today, so probably have to bear with this bad voice. So why data science is the most sought after job in 2015? Well, let's see the answers. Fortune 100 companies board the data science flight. So with the data science trends gaining momentum, legacy firms build up their data science teams. And let's get a salary band left. Okay, so how many of those Fortune 100 companies are actually using these data scientists? These companies basically are using these data scientists for certain very specific tasks. So I use the word certain and specific. The reason is those tasks were anyways, already being done within those organizations, but the essence was not data. Now they feel that their data is really important, and data has got a lot of values. They want to tap the all possible length and breadth of the data sets, and to analyze that, they need a data scientist, which is probably one step or a couple of steps ahead than a data analyst. Now, what kind of work would a data scientist do in a company like that? So I'm a data scientist. I've been working in this industry for the last 6 years. Okay, of course, before Howard actually gave this term called data scientist, I've been doing this job. And I can tell you the kind of transition I'm seeing in the industries is humongous. And transition specifically related to data science and building up a data science team. Now, for example, when I used to work with IBM long back, we were to think about delivering some analytics for certain client. So what we would do is we would look at the data and put that in an IBM SPSS or R at the time, or SAS, and do certain inbuilt operations. Well, that's because we did not have the entire knowledge of how we could go across different kind of data sets. And that's when we started figuring out that we could actually process all those data sets. I mean, like the videos, the audios, the PDFs, and so on and so forth. We thought we could use that data sets and actually started making a lot of sense. For example, we could figure out how many people will take leave in the next 3 months just based on the conversations, on the chatter conversations. That was a big jump for us, because we could then figure out what's our utilization going to look like. So that was one big reason. Now, of course, we still used to predict before the advent of data science that how many people are actually going to take a leave. But that was all based on intuition and not data. This time it was supported with data. Okay. Now, what could be the other reason that these organizations have started using data science? Well, they've seen, for example, there's a use case for a particular organization that deals with IP addresses. Sorry, not IP addresses, but IP properties. Okay, the intellectual properties. So they wanted to see how many research papers that are coming in every month, how many of them are actually useful, and they would want to find out first 100 which are useful. And that was a great thing, because that was a great idea, because that would lead to better quality of white papers or research papers. So what they did, rather than asking their scientists to actually go through all those research papers, they used data science. Now the exercise that used to get completed in around about a month time takes a couple of hours. That's a huge jump, because then they could use those scientists for something more meaningful. Now, second is analysts get a salary band lift. So we'll see how the salaries have gone up, specifically in the US and India, in Bangalore or in Mumbai or in Pune. So, top 6 predicted jobs in this decade in the US. Well, in the tech market, video game designer is the highest paid guy. I mean, even compared with a software engineer in Google, a guy with video game design capabilities in Nvidia or EA Sports would make far more money than anyone. Second was data scientist, which has seen a projected growth of 18.7%. Sustainability consultant, solar sales consultant, social media managers, and wind turbine mechanical engineers. Now, one good thing is that the other guys who are making good money are actually from this environmental background. So that's good. That's good for us. But in the IT job, in the IT, when I say IT, I also include the analytics. I also include the development that goes around. So I basically include, I would say, computer software. Data scientist is one of the highest paid jobs. If I compare it to a video game designer, if I compare it to a trading algorithm guy, if I compare it to investment banker, a hedge fund analyst, so all of them, they make more money than the data scientist. But eventually, what I've seen is all of them have started using some or the other kind of data science concepts. So it means that it's actually going to jump all over those particular kind of roles and probably become the highest paid job in the industry. Not just in the industry, when I say not just in the IT industry, in fact, any kind of job, data science would probably become the hottest possible skill in the market. So data scientist IT salaries, foreigners in US. So if you look at the Silicon Valley side, the H1B filings were 2081 and data scientist average base salary was 104,000. Then some in Texas and Dallas area, I think it seems like 61,000, and number of H1B filings were 29. If you look at the eastern side, salaries again on the higher side, but that's more with in the side you'll find people working on more of epidemiology, so they are more specific kind of people. And then on the north side, it's again around 65,000. So the range is 61,000 to 110,000. Of course, the one with 61,000, they're actually not data scientists. In most of the cases, the post is a misnomer. For example, if you go on LinkedIn, you'll see that so many people so many people say that they're data scientists, but they actually have been working in QA or in in software development for the last 10-15 years, and they suddenly start calling themselves as data scientists. So that doesn't help. So let's look at the median salary. It's around 94K, which is probably on the higher side if you look at it that way. Median salary in India is 625,000 rupees, which is not great, but still it's okay. I can tell you, people definitely earn much more than that, much more than that. If you look at the total pay kind of a thing in US, it's ranging from 63,652 to 137,560. I think these are a bit obsoleted numbers, or in fact, they are not correctly bound to the right title of data scientist. I think it's about it's not in the range of 150 if you're a good data scientist with a good understanding of AI and ML. So let's decode what is data science. So data science is the study of extraction of knowledge from data. It includes varying elements, machine learning, computer programming, mathematical skills, visualization, pattern recognition, and data engineering. So I'll call pattern recognition a part of machine learning only. And I'll call machine learning and pattern recognition a part of computer programming only. Okay. And I'll call computer programming, machine learning, and pattern recognition a part of data engineering. And I'll call visualization, machine learning, computer programming, pattern recognition part of data engineering. I would add one more skill, which is domain expertise. So a guy with experience in epidemiology would be much better than a guy not better, but then would be much different to a guy who comes in from a background of insurance or finance, right? Both of them are data scientists, but it's not that you can swap these two guys and ask them to do each other's work. It's not possible. Data science practitioners, data scientists. Okay, so we've got statisticians, domain SE, communicator, client-facing, artists, programmers. Yeah. So I would say a data scientist is a guy who knows how to use stats within an algorithm, who knows how to code that algorithm, apply that to a logic, and make it presentable. That's a data scientist guy. Now, when I say algorithm, stats, program, domain, it all applies to what? Data. It all applies to data. That means he should also have the skill set to know how to manage data. So it could be big data in case if it's really large. So he needs to have skills on big data programming. If the data is not huge, but if it's really sparse, they should know how to optimize data sets. If the data is, again, let's say huge, but it also has a variety, that means they should know certain libraries which could be used in order to, take whatever is there in files with different kind of formats. Statistical modeling and technical aptitude, business acumen, programming, data warehousing, and business intelligence. Okay, I would say BI and data warehousing probably are not that important. You should know this set of skills. You should know how to use data. You should know how to massage data. So when I say it's not important, but it does not mean you should not, you should not aim to have that skill. Of course you can. And you should also know SQL. If you know SQL, SQL is like the basic, basic building block of a data scientist skill set, architecture. Programming, well, programming is it's not that you need to be a programmer to develop an application. Think of a case where you're solving a problem on a data set and you come up with let's say a partial differential equation. So it could be a case where you cannot solve that partial differential equation within the system, or within a paradigm of a copy or a pen, right? So you probably need to know how to code that thing in order to solve that problem. Next is business acumen. Well, business acumen is certainly important. That's pretty much synonymous to what domain experience is. Statistical modeling and technical aptitude. So statistical modeling is by far the most important part. So if you aspire to become a data scientist, you've got to take courses in stats. That's like really, really important. Then you've got job roles: business analyst, data scientist, junior data scientist, decision scientists. So business analyst is pretty much the same kind of guy you've dealt with. Business analysts are the ones who would collect data, put that in an Excel, print some reports, closely align that with business, and come up with an answer. Data analyst, again, are the guys who probably would not be so close to the business, but would still be doing something or the other on the data sets, probably smaller data sets. We'll talk about decision scientist and data scientist. So what exactly could be the set of terms referring to here? I mean, one is data scientist, one is a decision scientist. Honestly speaking, I think both of them are pretty much the same guys, but a data scientist also need to be savvy with larger data management, which could be potentially big data and a large scale machine learning and all that. A decision scientist is the one, who's like super smart at statistics and algorithms and knows how to churn up a number which could be decisive in taking a decision. So that's more of a decision scientist. So I would say a stats heavy guy is a decision scientist, a programming heavy and a platform heavy guy with stats, of course, is a data scientist. So advantages of data science: disruptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics. And what you see is basically optimization process, optimization, evaluation. Okay, so prescriptive analytics. What in the world could be prescriptive, right, if it's not predictive? Or what in the world could be predictive if it's not diagnostic? And what could be diagnostic if it's not descriptive? So what it means here is, we've got a data set. First of all, we define what data set is. What are its boundaries? What are the descriptions about that data set? For example, what is the quartile range? What is the correlation? What is the summary? What is the median, mode? Blah, 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 blah. Then we can figure out what could be the reasons. We can find the correlation with the systems. Now, using all that information, we can actually figure out what will happen. Let's say you want to ensure that, you want to see whether a particular set of people in your bank, are they going to be an NPA, that means a non-performing assets? Well, you can do that seeing a predictive analytics trend for all those guys. But what if I ask you to ensure that 90% of your accounts are not NPA? So in that case, you'll have to apply one layer of logic above predictive analytics, which would be prescriptive. That means how can you make that happen? Okay, advantages of data science: mitigate frauds with proactive detection using predictive analytics and machine learning. So see, this particular diagram, it's fine. It's majorly into fraud. One biggest area in which machine learning is now being used is customer behavior. They want to figure out how customers behave so that they could make the best offers. They could put things which they would probably want to buy. They could figure out what their salary is going to look like. They could see how much of tax are they going to pay. All that thing can actually help us identify all the needs of a customer, which could help us serve our customers better. A customer could be one company, a customer could be an organization, a guy, a group of guys, whatever. One of the very strongly implementable area of data science is fraud. I worked in fraud analytics, and one of my endeavors was to find out whether a particular person who's trying to make a transaction, is that a legal transaction? Is that particular transaction legal or not? Now think of it in this case, how fast you need to make the decision, because the transaction is not going to be, a whole day process. A guy is going to make a transaction, and you need to ensure how we can do that. Of course, there's one particular area in which fraud analytics was used, and that for a short duration of time. But then we had that problem, and to be able to solve that problem was a big challenge. Plus, if you solve that problem, you save millions for your organizations each year, right? So just imagine if you could do that. Why would an organization not be happy to pay you few $100,000 if you can make them save millions of dollars a year? Data science career path, guys. Let me sip in some water. Data science career path. So let's see the job opportunities. So let's not think about something before July 1-2. So the term actually was coined by D.J. Patil, who was actually a member of Harvard Business Group also at the time. And Howard actually came up with this concept called a data scientist, and this term actually, and since then it's been a buzzword. And it's growing like hell. Everyone wants to be a data scientist nowadays. Why? Because you can actually make difference to bring in some logical difference to your organization. Okay, so if you see the trend, it's clearly, going up. I mean, the data is from Indeed.com, and currently the percentage growth is 80,000, which is super huge. Major companies using data science, that means major companies hiring data scientists are Amazon, Honda, then Walmart, Bank of America, all the social networks, Dell, Intel, and there are so many of them. Not just these, there are so many of them that are doing it. So if you're a good data scientist, you've got a good career, lying ahead of you. Real life application. Let's think about it. So BMW is using predictive analytics to find a place to park. So what they're doing is basically they're looking at the car plots, and based on that they are able to find out, based on the history, they're able to find out whether a parking place would be available or not. Okay, so let's say you start at home and you put up, let's say you use a GPS, you put your final location at let's say BMW office, whatever. So that could tell you that you will not find a place to park, even if there are some vacant places. And that would probably help you save some of the time, because if you, let's say you don't get a parking in a particular office, then you sometimes have to you have to come back, maybe you search for another building which probably not on the same lane, and so on and so forth. So basically it's nothing but predictive algorithms that's doing that. E-commerce, they're using it big time. Big time. Flipkart, Amazon, both of them. So, for example, if you go to Flipkart, first of all, you have to ensure that whatever your customer is looking for, that should be made available to that customer in next 25 seconds. If you cannot show the required product to the customer in the next 25 seconds, the customer is most likely not to buy it. Okay, so then you ensure that what customer would probably land up buying. Okay, that is one. Second, if as this pic shows, if someone bought bananas, they are most likely, they've also bought carrots. Or even think of it this way: you go to YouTube.com and you search for a video on, let's say, Tom Cruise. Now there is another guy, or a set of guys whose history on YouTube is pretty much similar to yours, and that guy saw a video on Tom Cruise and then jumped to a video on Tom Hanks. So you might just see, you may like talking about Tom Hanks, okay, a video on Tom Hanks. Application of data science, companies using it for customer acquisition and repeat business. Simple as that. So basically you could figure out who could be your potential customer. For example, we've got leads in the system, right? You know what a lead? A lead is something that can convert into a potential customer, and they can finally convert into customer if we take care of them and provide them the required things. So for any CRM based organization who have a good understanding of their leads, they could use data science in order to predict something that deals with their customer acquisition. So maybe for example, let's say you are a company that sells CRM business to big clients, and you know that, let's say, a particular kind of customer has an issue where let's say some kind of an issue XYZ. Now you can use data science to figure out someone with XYZ is going to buy a particular kind of a technology solution, and that is what you propose to that client directly, which is going to give you a high probability that the client is going to buy your offering. Customer churn prevention. So customer churn is like figuring out if a customer is going to use your particular service or not, or are they going to drop out of the service or not. Okay. So for example, if my let's say my total bill usage is going above 20%, above 120%, then there's a good chance that I might drop off that particular telecom vendor. And that's where these companies come into picture and offer you something which can help you reduce your bill. Okay, and that's called as customer churn prevention, by analyzing if a customer is going to leave or not. Demo, well, is data scientist really the sexiest job of 21st century? I say it's a big time yes, because of the quality of work. Most importantly, salaries are good. You get, honestly speaking, it's not that easy to become a data scientist. And that's because it involves a lot of skill set, and it's not something that someone can teach you in a matter of hours. It's a month-long preparation. Okay, but of course, doing certain courses can help you get started fast and can get you on the track, and from there you can pick up your journey of becoming a data scientist.